Hi everyone, Assalamu alaikum warahmatullah. I am MD Sohram Hussain, and today I am going to talk about one of the biggest problems in cryptography. That is, how do two people safely exchange secret messages over an insecure channel without a third party ever reading them? This is exactly what led to the invention of the RSA algorithm, which is one of the most important discoveries in modern science. Let's start from the beginning. The key exchange nightmare. In old school symmetries like Caesar or Visioneer, they both need exact same key, but how do they share that key safely? If Alice just send the key, a third party, Eve, that is the eavesdropper, grabs it and reads everything forever. This key exchange problem was a nightmare for centuries. That is, here we can see that key distribution problem arises because if two person using the same key and it needs to be shared fast, which led to the invention of public key cryptography. That is, with computers and early internet exploding, people desperately needed a solution. That's when Whitefield Diffie and Martin Hellman dropped a bombshell paper in 1976, introducing the revolutionary idea of public key cryptography. They showed it was possible to have a public key for encryption that anyone can use and a private key only the owner knows or the receiver. Their Diffie-Hellman method was the first practical key exchange, but it was based on discrete algorithms. The prime factorization, the one-way function. At MIT, three brilliant researchers named Ron Rivest, Adi Shamir, and Leonard Adleman read that paper and asked, can we build a system where the math itself protects the key? After months of trial and error, they found the perfect mathematical inspiration, the prime number factorization problem. And here's the magic. Multiplying two huge prime numbers is easy, but factoring the product back into the original primes is insanely hard when the primes are 100 plus digits long. Computers still can't do it efficiently. This one-way function become the foundation of RSA algorithm. How RSA keys are created. Let me show you step by step how they turned into a secure algorithm. First, choose two large distinct prime numbers p and q. Multiply them to get n equal p into q. This n becomes part of the public key because factoring n is so hard. Nobody can easily find p and q. Next, calculating the Euler's quotient, that is phi n equal p minus 1 into q minus 1, and then choosing a small public exponent e, that is co-prime to phi n, meaning GCD of e and phi n equal 1, that is also a public key. Now the clever part is finding the private exponent d such that d into e equal 1 modulo phi n. This d is the modular inverse of e. Only someone who knows p and q can compute D easily. This is the trapdoor. That is, the public key here is N and E and the private key is D or P and Q. Here, encryption and decryption with math. To encrypt a message M, anyone uses the public key N and E and computes ciphertext C, which is equal to M to the power E modulo N, which is super easy. To decrypt, the owner uses the private key D and computes M equal C to the power D modulo N, thanks to the Euler's theorem. This magically recovers the original message M, but without knowing D, which requires factoring N, an attacker is stuck there. Secure message exchange without meeting. That's it. RSA turned the prime factorization hardness into a practical way to exchange information securely. No prior secret meetings required. Here, Alice now can send messages to Bob using Bob's public key, and Bob will use his private key to decrypt the message. And no prior secret key needed here. RSA changed the world. How? It's the backbone of HTTPS, banking, digital signature, and secure internet commerce. The inventors even offered a $100 prize in 1977 to anyone who could break a small RSA challenge, and it took long 17 years. And this algorithm is still secure after about 50 years. The beauty of prime numbers. RSA is not just an algorithm. It is a beautiful example of how pure mathematics can solve real world problems. A simple idea that multiplying primes is easy, but reversing it is very hard, became the foundation of secure communication on the internet. Every time we use secure websites, send private messages, or make online transactions, here we are trusting this mathematical principle. This shows how powerful mathematics can be when it is applied to real life problems. So, the mathematical inspiration was prime number factorization. Thank you so much for watching the video.